Okay, so today's notes are comparing linear and exponential functions. So our goal for today is I can identify whether a function is linear versus exponential and vice versa. Go ahead and pre-rate yourself on how you feel about those two topics. That one topic and that one goal. Okay, so we're first going to talk about a linear equation. In the word linear, you should see the word line, and that's because a linear equation is an equation of a line. This is what we've been working with already. This should not be new to anyone, okay? So a linear equation is in the form y equals mx plus b, where m is your constant change, also referred to as the slope. Now, when I'm talking about the constant change, this is always going to be addition or subtraction. And then B is your initial amount. I spelled initial wrong. N-I-T-I-A-L. Initial amount. So we just spent a bunch of time doing problems like this. Like Sally has $2,000. Each week she puts $400 in her account. We have an initial amount and then her constant change, $400. Every week she's putting in money. So graph for this looks like you would have, for example, it's a line. So any line is going to work that's horizontal or sloped. But something, for example, you'd have like after 1 week she makes, I don't really want to say she makes $1. After 1 week, she discovers 1 gray hair. After 2 weeks, 2 gray hairs. 3 weeks, 3 gray hairs. So on and so forth. So it can look something like this. Or if we were talking about just the whole line y equals mx plus b, it could be a line going on forever and ever. It can be continuous or discrete. Okay. Linear functions have outputs that change by addition. So there is a common difference. So if you look at your x values, notice they're going up by 1, 0, 1, 2, 3, 4, 5, 6. But then if you look at the y values, this is going by plus 2, plus 2, plus 2, so on and so forth. So this is by adding 2. Therefore, it is linear. So if you get your next term by constantly adding the same amount, then it's linear. Okay, an exponential function is in the form y equals a times b to the x. So notice I didn't go over what x and y represent because x is just your input, y is your output. Same thing here, x is your input, y is your output. So what we have to go over is what are a and b. So in an exponential function, a is your initial amount. And b is your constant change, but this time it's multiplication or division. So if you see a problem that says that something is, she's getting 2 times more every week, or he is tripling his income, right? That's 3 times more. When I hear the word times, that implies multiplication, which is exponential. Now, we don't really use division, but technically, if you say that each week she loses half of the money, that's multiplying by a half, which is the same thing as dividing by 2. So we always use multiplication, but multiplying by a half is the same thing as dividing by 2. Okay, what would the graph for this look like? So if what I would do is like if I inputted 0, I got a value of 1, let's say. Okay. Now, at 1, it's going to double. So that's at 2. At 2, it's going to double. So now it's going to be at 4. And then at 3, it's going to double, let's say. And I'm just making one up. But notice what's happening here. you have a graph that looks like this. It's curved, okay? Now, the reason it's curved and that it's not going straight down is because if I go in this direction, right, and then I take half of that, take half of that, take half of that, it's never going down to 0, right? It's not going into the negatives ever if I keep taking half of a number. And the half is just an example. It could be a third or an eighth or whatever. Exponential functions that change are their outputs change by multiplication, by a common ratio. So if you look at the x values, once again, they go by ones, okay? But you're looking at your output. So this is times 2, times 2, times 2, so on and so forth. So there's still a constant change, but it's a multiplier, okay? All right, so let's see this. Consider each pattern, determine whether the growth is linear, exponential, or neither. All right, so let's look at the first one here. I'm going to look for a constant change. I always look for addition or subtraction first and see if the pattern continues. So I say, what do I do to a 2 to get it to a 3? I add 1. This is add 1. Add 1, you have to check all the way through. Add 1. So this is a constant change by adding 1. So since there's a constant change by adding 1, this is linear. And in parentheses, I can put because of adding 1. Or you can do plus, that's the same thing as adding. All right, let's check this one. To get from a 1 to 2, I'd have to add 1. To get to a 2 to a 4, I have to add 2. So now right away, I know it's not linear because it goes from 1 to 2. And it would have to be plus 1, plus 1, plus 1 if that's going to happen. So it's not linear. That's out. Now I'm going to check for exponential. So I'm going to say, okay, what do I multiply by? So to get a 1 to be a 2, I times by 2. Okay, that's good. 2 to 4, I times by 2. So far, so good. 4 to 7 is not times by 2. Not times by 2. So we already checked for linear. It wasn't linear. We just checked for exponential. It's not exponential. So this is neither. And that's because it's not increasing by a constant multiplier or adding or subtracting. All right, let's check this one. Plus 1 plus 3. All right, so it's not linear. So it'd have to be the same thing. Let's check multiplication. Times 2, times 2, times 2, times 2. So there is a constant multiplier. So this is an exponential function. And once again, the reason why is because it's times 2. Okay, so now what we're going to do is we are going to read through these examples. Okay, so you have 1, 2, 3, 4, 5, 8 examples, okay? For each of these 8 examples, we are going to look and it says, in each of the following, determine if the function is linear or exponential or neither. Provide a mathematical justification for your answer. We're also going to write an equation for that, okay? All right, so some of them are in words, some of them are graphs, some of them are tables. They're all a little bit different, so it's good to see this here. Okay, let's look at number 2. On Monday, Alex ate 3 jelly beans. Each day after, here's the key word, he doubled the number of jelly beans eaten on the previous day. So I want to know, is this linear or exponential? You could start thinking of the first 3 days, right? All right, he ate 3 the first day. He doubled it. So that is 6. And then he doubled it. So that is 12. So now I can realize that I'm multiplying. So if I'm multiplying, this is an exponential function. Exponential functions are in the form y equals a times b to the x, where a is your initial amount. So I'm going to do y equals my initial amount. So on the first day, he ate 3 jelly beans. And then I have times, which I like to just put it in parentheses, or you can put a dot right there. I like to put it in parentheses, the next number. And then in that, I'm going to put b is my constant multiplier. So this is doubled. Double means times 2. So there's a 2 and then to the x power. Okay. this is not equal to y equals 6 to the x. Okay, it's very important that you understand that. It is 2 raised to a power, and then whatever that is, you multiply it by 3. All right, so why do I know that this, what was the key idea here that told me this was exponential? I saw that word doubled. Doubling means multiplying by 2. All right, let's look at number 3. So I want to know, is this a linear function, an exponential function, or neither? So if you look at it, it's not a line, so it's not linear. If you look back at what an exponential function looks like, that curve that increases there, or it can be decreasing too, it is exponential. Let's write our equation. Y equals, A is our initial amount. So here's our initial amount. When x is 0, what is y? So this looks like the point 0.03 to me, right? So my initial amount is 3. And I'm going to put parentheses here. And I can put my exponent. So now I need to know what it's being multiplied by. All right, so now I'm going to look to see what I have. Here's 1. At 1, it's 6. At 2, it's 12. So how are my y values changing? They're doubling. So 2. Okay. Why do I know that that's an exponential function? Because my y values are doubling. Which means times 2, right? Okay, let's look at the next one. Time in seconds. So first I'm going to check out my x values, 0, 1, 2, 3, just to make sure they're in the right order and there's a constant change of 1 there. Now I'm going to look at my y values. My y values and see how they're changing. So to get a 2 to be a 5, if I was adding, I'm going to add 3. Let's see if that pattern continues. Plus 3, plus 3. The pattern does continue. So since it's addition, this is a linear function. My equation is in the form y equals, and then remember, it's your change times x plus your initial amount. So my change is 3, so 3x plus my initial amount. Your initial amount is when x is 0. What is y? 2. If you have y equals 2 plus 3x, that's equivalent, remember, because of the commutative property. All right, my justification, it's because it's increasing by adding 3. So adding is the key word there. All right, let's look at this next one here. So I'm going to look at my x values first just to make sure they're in order, increasing by 1, and they're definitely not, right? So let's see if we can get them in some sort of an order. So 53 would come first. And the output is 4. And then 58 would be input next, output 7. And then what comes next? 62 has an output of 6. And I'm going to stop right there because I can already see that there's no pattern here. So if you look at here, this is plus 3, and then this is minus 1. And these aren't going by increments of 1, but it doesn't matter because there's nothing happening right here, right? So this is neither. You shouldn't say there's nothing happening. There's not addition, a constant addition or subtraction, and there's not a constant multiplier. There is no equation. None. Justification, it's not linear or exponential is a fine explanation. Or you can say it's because it's not increasing by a constant, not increasing or decreasing by a constant. And that's at a constant addition, subtraction, or multiplier. All right, let's look at number 7. So I want to see the type of function. So first I'm going to look at my x values, 1, 2, 3, 4, 5. So that's good because I can just easily look at what's happening here. All right, so I look at 64 to 32. I would have to subtract 32. So do I subtract 32 to get this? No, because I would have been at 0. So it's not linear. So now I'm going to check for a multiplier, right? I'm going to check to see if I can multiply to get the next term. So I have 64 to 32. So how is 64 related to 32? I would have to divide it by 2. Remember, we're thinking of multiplying instead, so don't write divide by 2. That's equivalent to times by half, right? Take half. So take half. Yep. Half of 32 is 16. Half of 16 is 8. Half of 16 is 4. So this is an exponential function. I'm going to write my justification right now because it's multiplying by a half. And now I'm going to write my equation. Y equals my a value times b to the x. Remember, a is your initial amount. Your initial amount is when x is 0, what is y? So I look back at my table, and there is no 0 in it. So I have to figure out what 0 would be, right? So I want to be that this number, 64, is half of it. So that would be 128. So my initial amount is 128. And then I have times 1/2 to the x power. Okay, the last two are just equations making sure that you can recognize which is which. So if you look at this one right here, it's in the form y equals. And then I have a times b to the x. A times b to the x. So this is an exponential function. Notice there's no line for equation because it's already there. Justification, I'm going to say it's in the form. Y equals a times b to the x. Next one, type of function. So this is not multiplication. I can see that it's y equals, and then this is the same thing as 2x plus 4, right? Because of the commutative properties as I can switch them. So this is in the form y equals mx plus b. So this is a linear function. And I can say it's in the form y equals mx plus b. Okay, so now what you can do is you can go ahead and re-rate yourself on how you feel about telling whether a function is linear or exponential.